Greetings of the day. I am Dr. Vineet, Assistant Professor in the Department of EEE, MITS Madanpalle. So today I will discuss the effect of poles and zeros on the stability of any closed loop system. So at this point, we already know that the poles and zeros are the locations within complex S-plane where the system's response becomes infinite and zero respectively. So, and we also know that for the stability, the closed loop poles must always lie on the left hand side of complex S-plane. So how these poles and zeros are going to affect the stability of any closed loop system, that we are going to discuss today. So first we will take a simple second order system with unity feedback. So this is unity feedback system. So h of s is always going to be 1, and our transfer function is, so this is going to be our transfer function, and the reference input is r of s, and this is c of s. So in this feedback system, in this control system, we have gain k as forward path gain. So this gain is to be varied from 0 to infinity, 0 to infinity, and we will plot the moment of closed loop poles as this gain is varied from 0 to infinity. So first we will try to identify the open loop poles that are there in the system. So it has no zeros, system has no zeros, number of zeros is equals to 0. There are no zeros in the system, and number of poles are 2 poles are there. So these poles are lying at 0 and -2, right? So with this information we can proceed with our root locus diagram, and here first we will try to find out the angle of asymptotes. So angle of asymptotes will be theta. Theta is 2n plus 1 p minus z. So it will be nothing but 2n plus 1 p minus z is 2. 2 minus 0, that is 2. So n will be varied from 0 and 1. So only 2 asymptotes will be there because number of poles are 2 and zeros are 0. So all the poles will terminate at infinity only. So here in this case, if I will put n equals to 0, so it will come out to be 90 degrees, that is theta 1, and theta 2 is going to be, for n equals to 1, it will be 270 degrees. So two angles will be there, 90 and 270. And then we have centroid. So centroid will exist between summation of poles minus summation of zeros p minus z. So summation of poles will be nothing but 0 minus 2, that is minus 2 minus 0 divided by p minus z is again going to be 2 only, so it will be minus of 1. So centroid will exist at minus 1. So with this information, let us try to plot the root locus for this particular system, open loop system. So first we will mark the location of poles. So first pole is here, and it is at 0, and second pole is lying here, minus 2. So let us mark the region where the root locus is going to exist. So this region is going to be the part of root locus, because the sum of poles and zeros on the right hand side of this part is going to be 1, and this particular thing is not going to be a part of root locus because it is even. Even number of poles and zeros are lying on the right hand side of that part. So in between we will have our root locus, and let us mark the centroid that is at -1, and angle of asymptotes that is 90 degrees. This one is 270 degrees. So with this, now let us find out the breakaway point, because two poles are lying and in between we have a region of root locus. So in between these two poles will try to move and they will bifurcate to infinity. Between these 2 points only we will have the breakaway point. So let us calculate the breakaway point. So the simple method is 1 plus GSHS equals to 0. By putting this 1 plus K by S plus 2 and multiplied by 1 equals to 0, we'll get this equation s square plus 2s plus k equals to 0, and we can simply find out k equals to minus s square minus 2s, and dk by ds will be minus of 2s minus 2, and if we can put it to be equals to 0, the s will become minus of 1. So at this point the breakaway point will exist, and the root locus will move like this from -2. It will come like this, and here only the breakaway point will exist, and the roots will move towards the infinity from this point. So with this, we have plotted the root locus for this simple second order control system, and we can see that from this root locus, for any value of gain, maybe for infinity also, the system is remaining stable only, because the closed loop poles are always going to terminate at infinity on the left hand side of S plane. They are not going towards the right hand side. That is why this system is perfectly stable. Now we'll check what happens when we will add one pole in the system, one more pole in the system. So now the open loop transfer function, that is GS, earlier it was K by S plus 2. Now we will add one more pole in the system, that will exist at minus of 4. So for this system also, let us plot the pole 0 plot for this system. So first pole is at 0, that is this one, then -2, and somewhere here it will be the added pole. So now we'll try to see how this added pole is going to affect the root locus as well as the stability of this entire closed loop control system. So again we will calculate the angle of asymptotes, that is theta equals to 2n plus 1, 180, and p minus z. So now p equals to total number of poles is 3 and zeros are 0 only, 2 and plus 1, that is 180. So n is going to vary from 0, 1 and 2. Because there are no zeros, so all the poles will terminate at infinity only. So that is why 3 asymptotes are going to be there. So with this we can get the value, that is theta 1 will be 60 degree, theta 2 will be 180 degree, and theta 3 will be 300 degrees. Yes. So now the centroid will be summation of poles minus summation of zeros divided by p minus z. Summation of poles are going to be minus 2 minus 4, so I can write directly minus 6 minus 0 divided by 3. So it will be at minus of 2. So this will exist at minus of 2. So now let us draw all the asymptotes. So with 60-degree angle, first asymptote will go like this, and the second asymptote will go along the real axis like this, and the third asymptote will be a mirror of first asymptote. So all the three asymptotes we have drawn from minus 2 point, and now let us try to calculate the breakaway point, and let us try to see where the root locus is going to lie. So this point, odd number is going to be there at the right side, so that is why this point is going to be a part of root locus. But this thing is not going to be a part of our root locus because it is even, and again this particular thing is also going to be part of root locus. So here the root locus is going to exist. So when the gain is going to vary from 0 to infinity, this particular pole is going to move away from this point towards the left hand side. So this is perfectly stable pole. And now about these two poles, in between the region is going to be part of root locus. So these two will move, these two will move, these two will move, and somewhere there will exist one breakaway point that can be calculated by putting 1 plus GSHS equals to 0, that is characteristic equation, and we'll write the characteristic equation in terms of k, and we'll take the derivative of this gain k, and there it will exist. The roots of this particular equation will give us the value of breakaway point. So here we will get two breakaway points, that is one will be at s equals to minus 0.8 and another will be minus 3.15. So first breakaway point will lie at somewhere here, that is minus 0.8, and another will lie at here, somewhere here, that is minus 3.15. So this particular point, minus 3.15, is not going to be a part of our root locus. Why? Because this entire thing is not a part of root locus. So we can ignore this particular breakaway point, and the breakaway will exist between these two roots only. So from here the roots will terminate to infinity along with the asymptotes. So like this the roots will move. So it has, the root locus has three branches, all three are terminating at infinity. First branch, second branch, and the third branch. So now we have plotted the root locus for the third order system where we have added one additional pole, and by observing this root locus we can clearly see that for when the gain value, the open loop gain value k, is varying from 0 to infinity, after some time this root locus is moving towards the right hand side of S-plane. Means there will exist one value of gain, that is called marginal gain, that can be calculated using RH criteria. So for that value of gain, the system is becoming marginally stable, and beyond that value of gain the system will become unstable. So means as the gain is varying from 0 to infinity, when we have added one extra pole in the system, the root locus of the root locus of the closed loop system is moving towards the right hand side of S plane. Means system is becoming unstable with some value of gain. So that is undesirable. So in order to correct this, in order to further stabilize the system, we will add one extra 0 in the system, and again we will try to analyze the stability using root locus. So now we will simply add one 0 in the system, that is at -1 plus 1 we have added. And now let us draw the pole 0 diagram for this one. So first pole is at 0, then again we have at -2, again pole at -4, and we have one 0 that is going to be at minus of 1. So we have added one 0 at minus of 1. So now in this case, the angle of asymptotes are going to be 2n plus 1, 180 divided by p minus z, that is 3 minus 1. So the angle of asymptotes are again going to be, because only two poles are going to terminate at infinity, we have total 3 poles. 2 are going to terminate at infinity and 1 will terminate at 0. That is why we only have two asymptotes. One is going to be at 90 degree and second is going to be 270 degrees. So this part is going to be part of root locus. Now this region is not going to be a part of root locus, and again this region is going to be a part of root locus, right? And this is also not going to be a part of root locus because of even number of poles and zeros on the right hand side. So now we have calculated the angle of asymptotes. Now let us calculate the centroid. Summation of poles minus summation of zeros minus z. The summation of poles, that is going to give us minus of 6 minus of 1 divided by 2. So it is going to be minus of 2.5. So centroid will exist at minus of 2.5. So this 2.5 point will somewhere lie between here, that is minus of 2.5, and the asymptotes, that is 90 degree, first asymptote, second asymptote, that is 270 degrees. So now we have plotted both the asymptotes along with the centroid. Now this pole, when the gain value is going to vary from 0 to infinity, will move like this and it will terminate at this particular pole. Now these two poles are remaining. So these two poles will terminate at infinity only. And since their in between region is a part of root locus, so in between we will have one breakaway point that may be calculated by with the help of characteristic equation dk by ds equals to 0. So once we will get the characteristic equation arranged in the form of k, and we can find out the slope of k with respect to s, then we can be able to find out the value of breakaway point that will exist at somewhere minus of 2.8. So if it is 2.5, then somewhere here we will have our breakaway point, that is minus of 2.8, and along this breakaway point the roots will move towards infinity. So roots will move like this. and from this breakaway point they will move towards infinity. Their movement will be like this. Another pole will move like this. So now we have plotted the root locus plot for the system having added 0. So now we can see that as the gain value is moving from, as the open loop gain value is moving from 0 to infinity, the closed loop poles of the system are moving like this. First pole from this position to this 0, and all the remaining poles will move like this. They will move like this, and they will terminate at infinity along this angle of, along this asymptotes. So for any value of gain, the root locus of the system, of this particular system, is not moving towards the right hand side of S plane, rather it is remaining in left hand side only. Means stability is increasing. Stability is increasing as we are adding the zeros in the system. So with this we can confirm that stability of the system is going to enhance with the application of zeros.